Q41. A data engineer is building a file-based ingestion pipeline for a manufacturing analytics platform. The source system continuously drops files into a shared cloud directory that is also accessed by other applications. These files must remain untouched and will accumulate over time. The engineer needs a solution that can detect newly added files since the last pipeline run and ingest only those new files without duplicating previously processed data. Which tool should the engineer use to meet this requirement? A. Unity Catalog. B. Delta Lake. C. Databricks SQL. D. Autoloader. The correct answer is D. Autoloader. Why this is correct? Databricks Autoloader is specifically built to efficiently ingest millions of files from a cloud directory incrementally as they arrive. Detecting new files. Autoloader uses a mechanism called cloud notification or directory listing to track which files have already been processed by storing metadata about the files in a checkpoint location. Incremental processing. It ensures that only newly added files are ingested since the last pipeline run, perfectly avoiding data duplication. File longevity. It reads the data streaming style or in micro batches without modifying, deleting, or moving the source files, allowing them to remain completely untouched and accumulate in the shared directory over time. Why other options are incorrect? Unity Catalog. A. This is a data governance and security solution used to manage access control, lineage, and discovery across your Databricks workspace. It does not ingest files. Delta Lake. B. This is the underlying ACID-compliant storage layer format. While you can write Autoloader's output into a Delta table, Delta Lake itself is not an ingestion tool that automatically monitors external cloud file directories for new arrivals. Databricks SQL. C. This is a dedicated workspace environment optimized for running ad hoc SQL queries, building dashboards, and managing BI workloads rather than orchestrating file-based data ingestion pipelines. Q42. A data engineer is tasked with building a new Delta Live Tables pipeline to automate data transformations for a product analytics platform. During the setup process, they must ensure that all required fields are configured so the pipeline can execute successfully. The engineer is reviewing configuration options and needs to identify which setting is mandatory when creating the pipeline. Which of the following must be defined during the creation of the Delta Live Tables pipeline? A. A key value pair configuration. B. At least one notebook library to be executed. C. A path to cloud storage location for the written data. D. A location of a target database for the written data. The correct answer is B. At least one notebook library to be executed. Why this is correct? To create and run a Delta Live Tables DLT pipeline, the system fundamentally needs to know what code it is supposed to execute. In the DLT configuration, you must provide the path to at least one source code file, a notebook or a Python file, that contains your DLT definitions. Create streaming table, DLT.table, etc. Without defining the source library, the pipeline has no execution logic and cannot be created. Why other options are incorrect? A is incorrect. Key value pair configurations like custom Spark or pipeline settings are completely optional and used for fine-tuning performance or passing parameters. C is incorrect. While DLT needs a place to store data, explicitly defining a custom cloud storage path is not mandatory. If you leave it blank, Databricks will automatically generate and assign a default managed storage location for the pipeline's artifacts. D is incorrect. Specifying a target database schema is optional. If you omit it, the tables are still created and stored physically in the pipeline storage location. They just won't be published to a Metastore catalog for external SQL querying until you choose to define one. Q43. A data engineer and a data analyst are collaborating on a unified data pipeline for a travel platform. The engineer is building the raw, bronze, and silver layers using Python, while the analyst is developing the gold layer using SQL. The pipeline ingests data from a streaming source, but due to operational constraints, they now plan to migrate the pipeline to Delta Live Tables using a batch source instead. Which of the following changes will need to be made during the migration? A. Configure the pipeline to include notebook sources written in both SQL and Python. B. Redesign the pipeline so that all logic is implemented using SQL. C. Modify the pipeline to replace the streaming source with batch source. D. Redesign the pipeline so that all logic is implemented using Python. The correct answer is A. Configure the pipeline to include notebook sources written in both SQL and Python. Why this is correct. Delta Live Tables, DLT, support a hybrid operational model where a single pipeline can seamlessly execute source code written in both SQL and Python. During creation or reconfiguration, you can add multiple notebook libraries to the pipeline settings. DLT automatically resolves the dependencies and execution flow across those notebooks, regardless of the language used. Because the data engineer already has the bronze and silver layers written in Python, and the analyst has the gold layer in SQL, migrating to DLT does not require anyone to rewrite their code base. They simply configure the DLT pipeline to include both notebook sources. Why other options are incorrect. B and D are incorrect. There is no structure restriction forcing you to standardize entirely on SQL or entirely on Python. Forcing a rewrite would cause unnecessary development overhead. C is incorrect. While the source type is changing from streaming to batch, this is handled automatically by how DLT declares tables, e.g., changing streaming table to live table in SQL or dropping .readstream for .read in Python. However, changing the underlying definition of the tables is part of code refactoring, whereas configuring the pipeline architecture to accept both existing languages is a foundational setup requirement for this team's collaboration. Q44. A data engineer manages a Databricks job that executes multiple tasks every night. They've observed that each task experiences delays due to slow cluster startup times. To improve performance, the engineer wants to optimize how clusters are provisioned for the job using the cluster pool feature. Which action can the data engineer perform to improve the startup time for the clusters used for the job? A. Utilize the endpoints provided by Databricks SQL to execute the tasks. B. Replace all-purpose clusters with jobs clusters for running the tasks. C. Set the clusters to auto-scale in response to increasing data volume. D. Assign clusters that originate from a cluster pool to reduce startup delay. The correct answer is D. Assign clusters that originate from a cluster pool to reduce startup delay. Why this is correct. Databricks instance pools, or cluster pools, reduce cluster start and scale-out times by maintaining a set of idle, ready-to-use cloud compute instances. When a task requests a cluster that is configured to use a pool, Databricks does not have to wait for the cloud provider to allocate new virtual machines from scratch or wait for the operating system to initialize. Instead, it instantly grabs the pre-warmed instances from the pool, drastically slashing cluster startup delays down from minutes to just seconds. Why other options are incorrect. A is incorrect. Databricks SQL endpoints are specialized compute resources designed specifically for executing ad hoc SQL queries, BI tools, and dashboard workloads, not for orchestrating general multitask data engineering workflows or notebooks. B is incorrect. While jobs clusters are highly recommended for automated production workflows because they are much more cost-effective than all-purpose clusters, they still take standard cloud provisioning time to boot up. Switching to them will not solve the slow start delay on its own unless they are backed by a pool. C is incorrect. Auto-scaling allows a cluster to dynamically add or remove worker nodes based on the workload size. It does not speed up the initial startup time of the cluster. In fact, initializing additional auto-scaling nodes during a run can introduce further delays if not backed by a pool. Q45. A data engineer is responsible for a production-grade data pipeline that ingests structured logs from external systems. Recently, they've observed a decline in data quality and want to implement an automated mechanism to monitor the quality level during ingestion and transformation. Which tool should they use to address this requirement? A. Autoloader. B. Unity Catalog. C. Delta Lake. D. Delta Live Tables. The correct answer is D. Delta Live Tables. Why this is correct. Delta Live Tables, DLT, is the ideal framework for this requirement because it includes built-in automated data quality monitoring through a feature called Expectations, automated quality rules. You can define data quality constraints directly within your pipeline code, e.g., ensuring a column is not null or fits a specific format. Ingestion and transformation monitoring. As data flows from raw ingestion through various transformations, DLT automatically tracks statistics on how many records pass or fail these constraints. Actionable policies. You can configure the pipeline to log violations, drop corrupted rows entirely, or completely halt execution, depending on the severity of the quality drop. Why other options are incorrect. Autoloader. While Autoloader is excellent for incrementally ingesting raw files into the lakehouse, it does not provide native validation frameworks or data quality metric dashboards to monitor transformations downstream. Unity Catalog. This is a centralized governance and access control tool for managing data lineages, metadata, and user permissions across a workspace, rather than a pipeline execution engine designed to continuously track row-by-row data quality metrics. Delta Lake. While Delta Lake enforces basic schema constraints, like data types, at the storage layer, it does not provide a comprehensive pipeline orchestration mechanism or the automated data quality tracking dashboards that come with DLT. Q46. A data engineer receives a new data point with the following structure. ID string equals A1. Rank integer equals 6. Rating float equals 9.4. They are tasked with appending the new record to an existing Delta table named my_table using SQL. The engineer wants to choose the correct command that will successfully insert this record into the table. Which SQL command can be used to append the new record to an existing Delta table? A. Insert into my_table values A1, 6, 9.4. B. Insert values A1, 6, 9.4 into my_table. C. Update my_table values A1, 6, 9.4. D. Update values A1, 6, 9.4 my_table. The correct answer is A. Insert into my_table values A1, 6, 9.4. Why this is correct. Standard ANSI SQL, which Spark SQL and Delta Lake adhere to, uses the insert into statement to add new rows to an existing table. The standard SQL syntax is insert into table_name values, value 1, value 2, value 3. In this scenario, providing the values matching the exact order of the columns, ID, rank, rating, will successfully append a new record to my_table. Why other options are incorrect. B is incorrect. The placement of the clauses is inverted. Insert values. Into is invalid SQL syntax. C and D are incorrect. The update statement is strictly used to modify existing records already inside a table based on condition, typically using a set clause, e.g., update my_table set rating equals 9.5, where ID equals A1. It cannot be used with a values clause to append brand new rows to a table. Q47. During a data access audit, a data engineer discovers they lack the necessary permissions to query new_table, which is critical for an upcoming analytics task. They plan to request access, but first need to identify the owner of the table. What is the most effective way to determine who owns new_table? A. Check the permissions section within the Data Explorer interface for new_table. B. Use any of the available metadata views to locate the owner of new_table. C. Look at the owner field shown in the Data Explorer page for new_table. D. Inspect the owner field listed in the cloud storage interface where new_table resides. The correct answer is C. Look at the owner field shown in the Data Explorer page for new_table. Why this is correct. In Databricks, the Data Explorer, part of Unity Catalog, provides a user-friendly, centralized interface to view and manage metadata for catalogs, schemas, and tables. When you navigate to a specific table's page within the Data Explorer, the UI explicitly displays the owner field in the main overview panel. This field clearly shows a user or group principal that currently own the asset and possesses the authority to grant you access permissions. Why other options are incorrect? A is incorrect. The Permissions tab inside the Data Explorer shows which users or groups have been granted specific privileges, like select or modify, on the table. While the owner might be listed there, looking directly at the dedicated owner field on the main overview page is the most direct and effective way. B is incorrect. While you can query system catalogs or look at information schemas to find metadata, stating any of the available metadata views is too broad and inaccurate, as many metadata views only expose schema column definitions or table properties rather than ownership parameters. D is incorrect. The cloud storage interface, like AWS S3, Azure ADLS, or Google Cloud Storage, only tracks IAM permissions or object-level cloud ownership. It has no visibility into the logical table structure, metadata, or governance definitions handled internally by Databricks Unity Catalog. Q48. A data engineer and a data analyst are collaborating on a lakehouse pipeline. The engineer builds a raw, bronze, and silver layers using Python, while the analyst manages the gold layer using SQL. The pipeline ingests data from a streaming source. As they plan to migrate this setup to Delta Live tables, what adjustment must they make to ensure compatibility? A. No structural or language changes are required to migrate the pipeline. B. The pipeline must eliminate the multi-hop medallion architecture. C. The entire pipeline must be rewritten using SQL syntax. D. The streaming input must be replaced with a batch-based ingestion source. The correct answer is A. No structural or language changes are required to migrate the pipeline. Why this is correct? Delta Live Tables DLT natively supports both Python and SQL within the same pipeline, and it seamlessly handles both streaming and batch workloads. Language compatibility. You can configure a DLT pipeline to include multiple notebook sources written in different languages. DLT automatically coordinates data dependencies across them. Architecture support. DLT is explicitly designed to support and automate the multi-hop medallion architecture, bronze, silver, gold. Because the engineer's Python notebooks and the analyst's SQL notebooks can be run together as is, the team does not need to make structural design or programming language changes to migrate. Why other options are incorrect? B is incorrect. The medallion architecture is a best practice in lakehouse design and is fully embraced and optimized by Delta Live tables. C is incorrect. DLT allows a hybrid language approach. Forcing the team to rewrite everything into SQL is unnecessary and inefficient. D is incorrect. DLT natively supports streaming sources using the streaming table keyword in SQL or Spark.readStream syntax in Python. There is no requirement to downgrade to a batch source to use DLT. Q49. A data engineer is building a Python script to query a Databricks table using a variable named table_name. They want to execute a SQL statement that selects customer_ID and spend from this table. The query string is constructed using Python's fstring syntax. What method should they use to run the SQL query using the table_name variable? A. Spark.delta.sql. B. Spark.delta.table. C. Spark.table. D. Spark.sql. The correct answer is D. Spark.sql. Why this is correct? In Apache Spark and Databricks, the Spark.sql method is a standard programmatic interface used to execute arbitrary SQL query strings directly within a Python script. When you combine it with Python's fstring syntax, you can dynamically pass a variable like table_name into the SQL text string. Spark evaluates the string and returns the result as a data frame. Python code, table_name equals customer_sales. Hashtag executing the SQL statement dynamically using Spark.sql. df equals Spark.sql. F, select customer_ID. Spend from table_name. Why other options are incorrect? A and B are incorrect. Spark.delta.sql and Spark.delta.table are completely fabricated namespaces and do not exist within the Apache Spark or Delta Lake APIs. That C is incorrect. While Spark.table, table_name, is a valid Spark method, It returns the entire table as a data frame. It does not accept a raw SQL query string, like a select statement with specific columns. To select specific columns using that method, you have to append programmatic data frame transformations instead of a SQL string, like spark.table, table_name, a select, customer_ID, spend. Q50. A data engineer is analyzing performance of a Delta table used in production pipeline. They notice that the underlying data files are fragmented into very small units, which is affecting query speed. To improve efficiency, they need to compact the small files into larger ones using the appropriate command. Which of the following keywords can be used to compact the small files? A. Reduce. B. Optimize. C. Compaction. D. Repartition. The correct answer is B. Optimize. Why this is correct? In Delta Lake, the optimize command is used specifically to handle file compaction and resolve the small file problem. When data is written to a table incrementally, it often creates thousands of tiny files that degrade query performance due to metadata overhead. Running optimize takes these small files and merges them into larger, optimized files, typically targeted at 1 GB each. SQL, optimize my_production_table. Why other options are incorrect? Reduce. A reduce is a functional programming operation or an aggregation concept, not a SQL command used for managing or compacting data files in Delta Lake. Compaction. See, compaction is a descriptive name for the process being done, but compaction is not a valid SQL keyword or command in the Delta Lake dialect of repartition. D. Repartition is a programmatic Spark data frame method used to reshuffle data across an active cluster during a session. It is not the table management command used to compact existing files on a disk.